So here we are on page 25 of the workbook, Workplace and Apprenticeship 30. And this is part 3 of section 1.1. So this is the last little bit we're going to do. It's just a really kind of a short section, short example. But what happens when we plot points on a graph and it's non-linear? Okay, so we've been studying graphs that all the points form a straight line, right? Direct linear relation, indirect linear relation. And now we're talking about non-linear. That happens a lot. If you're graphing something, a lot of times the points kind of go up and down or whatever. And sometimes it's just a curve, right? So what can we learn about that, or how do we recognize that? Well, here's an example. Example 5 says a secondhand store has a policy that an item, if it's not sold, it drops by price by 30% every 2 weeks. A wool coat started out at $50. Okay. So create a table of values showing the price after 2, 4, 6, and 8 weeks. So look at this table of value over here. I have the solution in front of us here. And at week 0, that's before anything starts, right? The price is $50. It's always a good idea to start with kind of at time 0 or at the very beginning at 0. That's a good place for us to start with our graphing points. So it starts off at 50. After 2 weeks, okay, so here we go. This is where we start getting important. After 2 weeks, the price changes. So how does it change? Well, the original amount minus 30%. Now, if it's 30% off, that means it's worth 70% of its original value. So that's why they times by 0.70. Because minus 30% is the same as saying 70% of its original value, right? And so when you do that, you see that the new price, or 70% of that, is $35, and that's why this price shows up right there. Okay? So after 2 weeks, this is 30% off. Now, after another 2 weeks, we need to go another 30% off of this one. So let's say this coat hasn't sold. 2 weeks goes by, and the owner says, hey, we need to knock this down again by 30%. So let's find out what 70% of this price is now. And you have this number. Now the coat is on sale for this much. Well, another 2 weeks go by, and you have to drop it another 30%. And so this is your new price. Then another 2 weeks go by, and you have to drop it by another 30%, and so it goes down here. So if we were to graph these points, this is what we would see. We would see that because it's a larger value at the beginning, 30% of 50 is actually, a big drop compared to 30% of 17. See that? So when you're talking about percents, if you have a percent, like 30% of a large number, that's a big chunk. If you have 30%, the same percent, of a really small number, it's actually going to be really small, right? Proportionally speaking. So this is an example where if you were to connect the points after you plot them, you see that it's curved like this, right? Okay? So it's curved. So the rate is really changing. It's still 30%, but the amount of money, so the amount of money that it drops every 2 weeks changes. Okay? Not linear. So what this means is that we can find out what the individual rates are for each period. And that's what we've done here in this question. So the rate of change is the slope between the 2 points. So let's say, what does the question actually say there for us? Is the graph, use slope to support your answer. Okay, so they're saying prove that all the segments of this graph are not forming a straight line. Well, if they were not forming a straight line, that means the slopes of each section probably would be a little different. And that's what they're asking you to note here. Are the slopes of 2 different sections different? If they're different, then it's not a complete straight line. Does that make sense? If it was a complete straight line, then the slopes of any 2 sections should be identical. All the sections actually would be identical. But if the slope changes, then the 2 sections you would calculate, they would not be the same slope. So that's what they're showing you here. Section 1 has this slope. Section 2 has a different slope. All right. So please take the remaining time of class, and you know what? I guess I'll get you started on this, okay? But we're going to continue our build your skills practice questions. So yeah, let's do 11 together actually, just so we can make sure we get a good start on this. So Ampreet owns a cafe. One popular breakfast item is bottled orange juice. Ampreet tracks sales to find out how many bottles he should order per week. The table below indicates the total number of bottles sold by the end of each day. So on day 1, he sold 56. On day 2, 108. Day 3, 162, and the numbers keep growing. Now, does this form a straight line? Well, we could graph them and then check. Or what we could do is we could check, so a lot of you have identified this, that points that form a straight line, if these go up by a constant amount, and that's 1 each time, 1 day each time, then this should also go up by a constant amount. So if we could take a quick look and see if the difference between all these points are the same. So what's the difference? 56 and 108, what's that? That's going to be, was that like about 52? Okay, so that goes up by 52. What about 108 and 62? That's going to be what? Oh, that's 54. Do you see how these are not the same? So that means this is going to go up by 52, and then it's going to go up by 54, you see? So it's not going to be linear. And that's a quick way that you can tell. All right, so let's go ahead and graph the data shown. All right, so here's our grid. Some things we want to do is we want to find out how we can make good use of our graph. So the days are going to be the independent, right? So after 3 days, how many did I sell? After 5 days, how many did I sell? We always measure the number of bottles sold. We don't say, oh, when I hit 215, now I have to check on what day it is. No. After this day, you check how many you sold. So days are going to be on the bottom. Days and bottles over here, right? Okay. Now I want to use the graph to the fullest extent, so I'm going to go, I have to have 6 days in here, so let's start with 0, and I got to go to 6. There are, I think, are there 15 in this one? So let's see, if I go, well, I guess I could go every 2 squares would be a day. Would that work? 15, so let's see, 1, 2, 3, 4, 5, 6. That is a great use of the space there. Okay, so 15 divided by 6 days. Okay, so this is how you can find this out to be exact. You've got 15 squares, and you divide it by, you need 6 days in there. So that's 2.5. Okay. No, you want days per square. My bad. So you want how many days are each square going to be worth? So let's do that the other way. 6 divided by 15. There we go, 0.4. So 0.4, if each one of these squares were 0.4, that means 6 would be at the very end. But that's not a very nice number. So let's just round that up to 0.5. So that's where I go. Each square is 0.5. You see that? So if you want how many days per square, you just do that division and then round up to the nearest sort of number that's reasonable. Or just kind of trial and error and try and use the best. Okay. Bottles. Now, I need to go from 56 to 321. This 56 really is, we could start at 0 here. That's not a big deal. We need to go to 321. So I need to go from about 0 to maybe 350 or 400 here. You see that? So let's say I want to go to 400. So how many days, bottles per square do I need? Well, let's say so 321 divided by 15 squares. So how many bottles per square? 21.4. Okay, so we round that up. We could round that up to 25. So that means that each square should be about 25 bottles. See that? 25, 50, 75, 100. So that's going to get us to, about, oops, does that look right here? So let's see, that's 1, 2, 3, 4 squares. 1, 2, 3, 4. It's 200. 2, 3, 4. That's 300. And 1, 2, 3. Okay, this is going to be 375. Oh, that's fine. We don't need 400. We just need over 321, don't we? Okay, see how that works? And you can fill in all the numbers if you want, but you really don't have to. Okay, so that's the way you can set up your scale. Okay, so take the number of the range here, the number of days divided by squares. The number of bottles divided by squares, always round up, and then you'll be able to fit everything on. Okay, so day 1, 56. So here we go. Over to day 1 and up to 56. Okay, we're going to have to just kind of guess there, but it's going to be right about there. Day 2 is 108. Day 2 is 108. About there. Day 3 is 162. So here's 150, 175, so 162 about in between there. Day 4, 215. So over to day 4 and go up to 215. It's about halfway between 200 and 225. Day 5 is 269. About there. And day 6 is 321. Day 6 is about 321. Okay. Now, that looks pretty close to being linear, but we already found out that it's not quite exactly linear, is it? The differences are not the same, so they're going to be pretty close, but not quite the same. All right. Now, we could draw a line connecting those two. That would be a good idea. Connect all these points. You could draw a straight line through those points with your ruler. That would be a great idea to try and do that. However, it's not linear, so it's not going to be able to go through all the points. So let's see what B says. B says, does the graph appear to be linear? Well, kind of say yes. Calculate the slope for 2 sections of the graph to check. So yes, ... So let's calculate the slope of 2 sections. So we can go back to our data table here, actually. Remember how we did this before? Let's calculate the slope of this first section, and then we'll calculate the slope of another section. Let's just take these two. So the slope of the blue, let me just cut and paste this for us to the next page. Are you guys following along so far? Is this making sense? Okay, so I'll put this maybe up at the top here, I guess. Oh, that didn't work. Didn't go to the top at all. Come on now. Okay, here we go. I'll put it down here. Okay, so the number of bottles, this is the y, so we're going to do 108 minus 56. So the blue slope is going to be 108 minus 56, right? Because we have to take the difference of the y values and then divide it by the difference of the x values. 2 minus 1. Right? So does that match with the graph? Well, 108 is about here minus 56. See? Difference in y values. That's the height difference between those 2 points. 108 minus 56. And then the run, the y values would be the difference between 2 minus 1. See that? So I'm calculating the slope of this line here. And what is that? 108 minus 56 is what? 48? So what is it? 48? 48 over 1, right? Is what? Oh yeah, wait. I did say 48. What am I saying 48 for? Okay, 108 minus 56. 52. 52, thank you, over 1, right? So 52, and that's going to be bottles per day. Okay, we don't need the units because we're just focused on the numbers right now. So let's do the red. Oh, and we did this already. Remember we wrote down 52? So let's see what's the difference between these guys here. So 269 minus 215 divided by 5 minus 4. Okay, let me redeem myself here. It's 54. 54 over 1. So you see how these slopes are different, slightly different? So it's not linear. Not linear, and there's the proof. two different slopes for two random different sections. Okay? All right. So, we are at the point where we're coming to the end of section 1.1. So, next up, you're going to be finishing the questions from 1 to 12 that you've done to build your skills. So that's what you can work on tonight. Try and finish all those questions. Tomorrow I'm going to give you some time to work on practice your new skills, and you'll be, next class. You're going to be submitting practice your new skills along with your 1 to 12 questions. Okay? So that's kind of what's up next. Do you have any questions? Okay.